something called the difference quotient. The difference quotient is just a fancy name for something else. So let's look at that something else. Let's pick 2 points on this curve. And this is the curve for y is equal to x squared. We should know what that curve looks like. If we put 2 points on the curve, let's call this x1, comma, y1. We'll call this x2, comma, y2. Okay, that would be the ordered pairs for these. Now, if I wanted to find the slope between those 2 points, I could say y2 minus y1 over x2 minus x1. That describes the slope between the 2 points. Now all I'm going to do is now use different terminology for all of this. So I think most of you know that if I had y is equal to x squared, it would be proper for me to say f of x is equal to x squared. That's called my functional notation associated with the function itself. Functional notation. So if I want to do f at x1, it would probably give me a y value. So f at x1 will also relate to f at x1 will relate to what y is equal to. And so in this case, that would be the y value of the point. So this would be y1. If I did f at x2, that would be equal to the y value of the ordered pair, which in this case would be y2. So we can also rewrite this as, let's do some fancy language here, and let's call this x1 comma f at x1, because that represents the y value of that ordered pair. And over here we can describe this as x2 comma f at x2 using my fancy notation, where this is just representing the y value of the ordered pair. F at x1 represents y1 and f at x2 represents y2. If I want to describe the slope between those 2 points, this would be f at x2 minus f at x1 all over x2 minus x1. Again, isn't that the same as this? They are identical to each other. They're just using fancier terminology. Now let's go to another way to describe this. Let's say this first point we're going to call x1. Let's say that x2 is over here, but I'm going to describe that as just being h units away from, so h units away from x1. So I could describe this as x1 plus h. That would be the x value, because I'm just h units beyond x1. So up in here, this could be described as the x1 plus h comma f at x1 plus h. Wouldn't that be the same thing? This is the x value, this would be the y value. This is the first x value, this is the second x value. So when I do that, I just moved over h units, and so therefore the x value would be x1 plus h comma f at x1 plus h. And now we're going to describe what we describe as the difference quotient. Now, I don't really need to put x1, but I'm going to call this just simply, just to make our lives a little bit easier, let's just call this x. And if I went over h units from that, this would be x plus h. So up in here, the point on the graph would be, this point right here would be, of course, be x comma f at x. And that would be the ordered pair for that point right there. And this other one, since it's just h units away, its ordered pair would be x plus h comma f at x plus h. And so if I wanted to find the slope between these 2 points, I could write f at x plus h minus f of x all over x plus h minus x, because this would be the x2, this would be the x1, this would be x2, this would be x1. And if I subtracted those, f at x plus h minus f of x, and x plus h minus x is simply going to be h. So we have over here what we could describe as, I'm going to do this one more time just because it was kind of hard to see on the other paper. So if I look at these 2 points, this being x and this is being h units away from it, so this would be h units away, so this would be x plus h. And up in here, when I move up here to the point on the curve itself, we'll have this point to be x comma f of x, and this point up here to be x plus h comma f at x plus h. That would be the 2 points. So the slope between these 2 points be f of x plus h minus f of x all over x plus h minus x, giving me f at x plus h minus f of x all over h. X plus h minus x is going to give me h. And what we've done is we have derived the difference quotient. And we'll do some examples of utilizing the difference quotient, but what is the difference quotient anyway? All it is the slope between 2 points, that's it. So the difference quotient is simply the slope between 2 points. And we will use this many times throughout this course, because slope is going to have several different meanings to it, but slope is just the difference, the change of y over change of x. Change of y over change of x, it's the difference quotient, and it's also the slope between 2 points. And that's what we got to take from here. So what we've done here, we've actually derived the difference quotient. This is derived the difference quotient. So all we did was find the slope between 2 points. That's all the difference quotient is.